AITP-LA has been around for many years. We've got an active board this year, and we're soon we'll be having a strategic planning meeting for next year, and we welcome new voices, fresh ideas, and several of you have expressed an interest in participating, and so we will be reaching out to you for that. AITP is basically provides programs nearly every month on a variety of technology topics. The goal is to keep our members current on the latest technologies and to give them a starting point for how to manage those technologies. One of the obvious advantages of being in our group is our in-person meetings and the networking. So we're in the process of thinking of a more effective way to network in these virtual environments. So there's more to come there. Anyway, we look forward to more of your participation in our planning meeting. So I think with that, I will turn it over to Nilu, who will say a few words before our speaker starts.
So before we start, just a few logistics. We are a small group today. So I'll just say, if you're not speaking, just keep yourself on mute. And you can keep your video on or off, it's up to you. We are going to be recording this, and it's going to be posted on AITP website. You can always go back and check it out over there. You can ask questions by posting on chat, or wait towards the end and you can ask questions to our speaker yourself. With that, I'm going to welcome Dr. Gupta, who's our speaker today. So Dr. Gupta, if you want to turn on your video, and you already heard some of the conversations that were going on. I think we already have some questions coming out for you.
Sure.
Yeah. Regarding like how robotics can be used in like practically in the household and not just industrial. Dr. Gupta has a lot of years of background in robotics, and he's going to share recent trends in robotics and also provide a glimpse into the future today. His research interests are physics-informed artificial intelligence, intelligent decision support systems, and human-centered automation. And Dr. Gupta has published more than 400 technical articles in journals, conference proceedings, and edited books. And he has also delivered 170 invited talks. So with that, I'm going to hand it over to you, Dr. Gupta.
So today I'm going to basically talk about robotics and AI, and in particular, how AI is impacting the field of robotics and how this AI-powered robots are then enabling innovations and improving quality of life. So my personal passion is basically eliminate need for people to do tasks that they do not want to do, should not do, meaning that these tasks are dangerous, people are going to get hurt doing it, and therefore we should not allow them to do those tasks or tasks that they cannot do. So, for example, going to a place which is not inhabitable for humans. So obviously human cannot go there, and therefore we need to figure it out some other way to get that task done. So if you think about these kind of objectives, then we have to start thinking about robotics and automation. So the field that I work in is basically called human-centered automation. And here the idea is that we want to use robotics and automation technology to amplify human abilities. And this is in terms of power, control, and decision-making. And if we can enhance human capabilities, then we can increase productivity, we can basically reduce health risks, and also enable innovation. So that's roughly the theme behind human-centered automation. So I believe that every problem can be solved with the right team. And we are now beginning to look at it, the following notion of team. So we will have humans. So we strongly believe that humans are going to be a critical part of every team that we imagine. Then there will be robotics, which is the hardware, which is going to enable or make human more capable. And then there is going to be AI piece, which is going to also enhance humans' decision-making capabilities. So it's a combination of human, robots, and AI, which then combined together can actually help in improving quality of life for everyone. So that's the vision with which we are working. So the first question that I get asked, what is a robot? So, in general, people would say that there are two kinds of platforms out there which are called robot traditionally. One would be a robotic arm, which is mounted on a table or some other workstation. And then there'll be a mobile platform, which may be carrying sensors and moving around. And increasingly, we see platforms where a robot arm is mounted on a moving platform. So this is what, in general, will be referred as robot. And then people have been expanding this notion of robot. So you have Roomba, which is considered robot. You have quadrotors or drones. Those are also considered robot. Then you have this legged robot like Spot robot featured here on the right-hand slide. And then you have the Da Vinci robot for surgery. Many people consider driverless cars or self-driving cars as robot. Then you have these legged robots. So these are all broadly considered robots nowadays. And when I'm discussing robot, all of these will be basically considered as part of being robotics. So before I get into, basically the main discussion point, I just wanted to show you some videos of the different kind of robots which are built by my research group. So the first robot that I want to show you is this flapping wing robot. So we got involved in building these flapping wing robots in 2005. And the idea was that if you can build a platform which flies by flapping its wings, then you can have much quieter flight than what a rotary wing vehicle can provide. And also these platforms are significantly more maneuverable, so you get much better performance than you get out of fixed wing flight. So we have done lots and lots of flapping wing platform over the years. We have also worked on robotic fishes. So here the idea is that, basically build small scale platform which can actually basically swim like a fish. We have done a lot of work in building robotic hands. So in this case, the idea is that you're creating these robotic hands which can lift things up. Now, in this case, the idea is to build a really low-cost hand. So in this case, we are using a technology called layer jamming, which allows us to change the stiffness of the fingers, which then allows us to basically grasp the object in a safe mode. But then when you need to lift it up, then you can actually turn on or make the fingers very stiff, and therefore you can go ahead and push things with force. So we've been doing a lot of that work. We have also adopted a commercially available legged platform and put them to good use. So this is the work where we were looking into how we can do disinfection using basically these legged platforms. So we got this commercially available Legged robots, we mounted them with basically this chemical dispensing units, then that allows us to basically walk around and spray chemicals. So that's another example of robotic work done in our lab. And this technology has camera, so when you spray, you can see where you're spraying, what area is sprayed and not sprayed, and so on and so forth. We have been also doing some work in mobile manipulation. So this is a technology where, we're basically doing spray painting using robots. So idea is that robotic arm mounted on a mobile platform is carrying a spray gun, and then you can go ahead and get the robot to start doing spray painting. So that's another kind of robot that we have worked on. We have taken a robotic welder. So there are lots of commercially available robot that can do welding. So in our lab, we converted a robotic wire arc welding platform into actually do 3D printing with the robot. So you have seen plastic 3D printers where you can basically extrude out plastic and do printing with that. Same idea, except that in this case, we are going to do 3D printing with metals, and we will convert a robotic welder into 3D printer. So in this case, we are printing with the steel, basically. So very similar idea that you layer by layer deposit material using a arc welding robot, and then you build the 3D structures. And any material that can be welded can be used in our system, and we can use that to basically create 3D metal shapes. So that's the another example where you can use robot in an interesting way, and which we have. And now, if you don't like the roughness of this material, you can go ahead and do some light machining, which we have also done, and then it can give you very super smooth surface, and you can have a usable part. We have also built a robotic assistant which can help humans when they are doing challenging tasks. So in this case, the task to be done is lay up a composite part on a mold. Usually this task is done by 2 humans. One will hold a sheet and one will do the layup. In this case, we are assisting this human with 3 robots. So human only does very challenging part of the task. Parts that are easy are done by the robot. So holding the sheet is pretty easy. Robot can do that. And the relatively flat region also be laid up by the robot. So idea here is that rather than 2 humans working for few hours, 1 human only works 50% of the time, and then you can basically get the part done. So hopefully human only does interesting things. All the boring routine things are done by the robot. So that's another example of work that we have done. We have also done a lot of work at very small scale robotics. So here basically, we want to manipulate biological cells. So these biological cells are basically 5 to 10 micron in size. So how do you manipulate them? So if you want to manipulate a biological cell, how do you do that? You're not going to have a physical robot going and grabbing it. So what you do is that you have in the fluid where the cells are floating, you're going to insert some silica particles. And then you're going to use laser to manipulate those silica particles. And then you can use those silica particles as the fingers to manipulate the cell. So in this case, we are able to grab the cell using these silica particles and move the cell around. We can position them. So lots of interesting experiment where you want to study cell-cell signaling, cell-cell communication, this type of automation technology helps people in conducting those experiments. So this is just yet another example of robotics technology, but now size scale is, so a human hair is supposed to be 100, healthy human hair is supposed to be 100 micron. So this is 20 times smaller than the width of the human hair. So that's how small scale we are operating. So that gives you, good flavor of the kind of robot that we built. So maybe good time to take a pause, and if there's any question, I'm happy to answer. Vivek, you had a question, right?
Yes, I put it in the chat.
Okay. So basically the dog, these robotic dogs start around $15,000 right now. The good one which work. There are all kind of knockoff technology which may or may not work, but around $15,000. And of course, the cost can be significantly higher than that. Any other questions or any other thoughts that you would like to share before we...
Yeah, hi, can you hear me?
Sure.
Yeah, I had a question. I had a few actually. One of the things that fascinated me was the 3D printing, the robotic arm that 3D printed metal. Is the material of essentially the filament, is that something that had to be specially researched, or is that something that industries are already using?
Yeah, that's a standard welding material. So there's
Oh,
nothing special about it. It's just a standard
Okay.
material that's used in welding. We're just using the same material.
Okay, because I thought there would be like certain, I don't know, complications or challenges by attending the 3D print metals as you're heating it and you're okay. And then the other one was when you demonstrated the robotic hand and the arm, you mentioned that the fingers stiffen. What mechanism do you use to stiffen the fingers on that robot arm?
So there's a physical phenomena called layer jamming. So what happens that you take some rough compliant sheets, could be even paper, or it could be other thin sheets, but they need to be rough. And you encase them in a bag. And when you apply vacuum, then sheets basically come close contact with each other, and therefore that's how the stiffening happens.
Okay.
So the phenomenon is called layer jamming.
Layer jamming.
Mm-hmm.
Sorry, writing this down. And then kind of the last one that I had. In the first video you showed a winged robot, and that was phenomenal to watch. What is the, sorry if this is a little bit general, but what is the development process for novel robots such as those?
So, different robots require different kind of things. Then when we got going in this field in 2005, I mean, there wasn't a whole lot available at that time. So we had to do a lot of trial and error type of tests.
I see.
Since that time, there's a lot of sophisticated modeling available now. So a lot of knowledge is out there, how flapping wing platform work, what shape to use, how to optimize it. So
right.
Development process today would be quite different than what we had in 2005. But we have been working on it since, basically from 2005 to around 2018. That's how long we worked on that project.
Okay, so the project has been the project completed.
Yeah,
Essentially.
2018 we wrapped up that project.
Okay. You mentioned actually sophisticated models. Do you know who develops these models and if they're available for like the public at all?
So most of these models are developed by basically, aerospace engineers and professors, right? So, nothing available for general public, but if you reach out to professors who develop those models, you can get your hands on those models, right?
Right. Because
again, behind the scene, they're running very sophisticated computational fluid dynamics simulation engines, right? So it's not
Right.
something that you will be able to run it on your home.
Yeah, I'd imagine.
You will need a cloud computer to run it at least. So yeah.
Right, because those I don't know. I imagine a robot like that is very complicated as far as like mechanical is concerned. It's
Sure.
significantly more complicated. So I was just wondering about the entire process because that must have not been simple. Okay, that's all I have.
Sure. Okay. Sounds good.
So I have one question. So I know I was watching and it looks like some of the videos seemed like it was like out of like a sci-fi movie, right? So is there like any like development done for like general public, as you mentioned, like anything like on the household, because these were all like for industrial, right? Or on the medical side. So that, yeah.
So let me finish few more slides, then I will be able to happy to answer that question, why household robots are not there, and unfortunately, nothing sophisticated is likely to manifest over next few years, right? So I can try to answer that question in few minutes once you have a little bit better context of why this technology currently the way it is, why it needs very structured environment and why without that it's difficult for this technology to work in. So,
Sure.
okay. So the role of robots have been largely, in the past, when people said robots, everybody's thought on that was, okay, let's reduce cost by deploying robots from dull, dangerous, and dirty tasks. So that was, DQ, dull, dangerous, dirty was the, industry word. So dull means something where people are going to get really bored and then they'll start making mistakes. Dangerous means, if somebody is, doing a task where there's a potential for getting themselves hurt. Dirty means, so let's say you're doing sanding or polishing or some task where you are working on very unpleasant setting, and therefore nobody wants to get the job. So that was our original, perspective. That okay, let's reduce cost by deploying robots in dull, dangerous, dirty tasks. But people were largely looking at it, robot will do what people do. The modern perspective is, let's use robot to do things which human absolutely cannot. So for example, when I was showing you example of manipulating biological cells, I mean, that's an example where a human cannot grab those cells with their hands, right? So in that case, if you want to, do some interesting experiment in biology, you will need robots, and these robots are going to then enable you to do interesting experiment. The second aspect is that rather than worrying about replacing a human task with a robotic task, why not focus on increasing human productivity? So when I was showing you the composite layup task where a human was being assisted by 3 robots, so there are tasks, where human skill matters and human will enjoy working on the challenging things. So you want human to do that and let the robot do routine work. And that way, in that particular task, if you work with the assumption that one human worked 50% of the cycle time, then productivity boost was factor of 4. Because in that case, so let's say 2 humans were taking 1 hour to do it, and now if you have 1 human doing 30 minutes, you have basically boosted human productivity by a factor of 4. So that's another interesting perspective. Why not just help human become more productive? Another interesting perspective that's emerging is basically enhance opportunity for people with disabilities, because once you start using robots, then certain jobs which were not accessible to people with disability, potentially they can work on those jobs because now certain barriers they had are removed. So this is more interesting perspective that expands the role of the robot makes robot much more useful, and you can justify why robotics should be used. So that's kind of how thinking is changing in the field of robotics. So now I'm just going to show you some applications where robots are being used, and then we can go and talk about Nilu's question about why we are not seeing more robots at home. So robots certainly increase throughput, improve quality, and prevent injuries to human in manufacturing setting. So in lots of manufacturing applications, you will see robots being used, all the way from basically doing welding to basically, performing material handling, or even doing some assembly or painting. So you see these robots routinely in manufacturing application. A mid-sized robot arm cost about $50,000. Now, lower end, you can get one for $20,000, but mid-size robot arm will cost about $50,000. So that gives you some idea about the cost involved in just acquiring the hardware. And then, of course, if you put sensors on it, and if you put sophisticated AI software on it, then that $50,000 acquisition cost will turn into $150,000 acquisition cost. So that's the cost of the robot that we are talking about in the manufacturing application. And this will be a little bit relevant information when I try to answer Nilu's question that when are we going to see robots at home? Right? Now, robots are also becoming quite useful and popular in healthcare. On one hand, you have these Da Vinci robots, which surgeons can use to do minimally invasive surgery. On the other hand, hospitals are beginning to deploy robots which can do autonomous disinfection via using ultraviolet, beams on the robot. Now, some of these Da Vinci type of robot, which are being used as assistants for surgeons, are very expensive. So we are now talking about millions of dollars. So again, very useful, but cost is quite high. And again, you can train the people to use the robot. You can engineer the environment where these robots can be used. Robots are also gaining popularity now in agriculture. So people believe that this would be a big application area for robotics. And the reason is that robot can basically help you do the proper irrigation, pesticide application. Robot can do harvesting. So there are lots of interesting things that can be done with the robot, and robot can greatly reduce waste in agriculture. And the cost of robots, again, are comparable to the cost of robot that you see in manufacturing. They're not as expensive as medical application, but they are, similar in price as you see in manufacturing. Robots are also gaining a lot of popularity in construction nowadays because a lot of construction jobs are basically pose, challenges for humans, and people get often hurt. So now the question is, can you use robots? So again, robotics is becoming quite popular in construction. You can increase the build speed. Hopefully you can do, build operation 24/7 without taking a break. You can prevent injuries to humans. So these are all drivers for people to look at robots in construction. Now, on the other end of the spectrum, robots are also gaining a lot of popularity in logistics and warehouses. So as during pandemic, everybody was purchasing things sitting at home. Many of the warehouses were busy deploying robots which can fetch the things from shelves to the worker who will pack them and ship them. These robots are much lower cost than the robots seen in manufacturing. However, these robots are just fetching, basically carts. So that's kind of what's going on. But again, now you can design interesting warehouses. You can have very narrow aisles. You can have very tall shelves because you're no longer, again, being constrained by human form factor. So you can have lots of innovation opportunities in the warehouse. Robots have been in space for a very long time. Obviously, without robot, we will not be able to explore Mars with the current technology. So the case for robots in the space is obvious, and these things are super expensive. Now we are talking about, really, really crazily expensive platforms. There's a tremendous interest nowadays in using robot in the field of assistive technologies, and people use this in two different ways. One way is where you have, robot that you wear on your body, and or could be exoskeleton, could be prosthetic limb, and then you also have social robots, which are robots in somehow humanoid form, which can interact with people. And the reason for this is that robots are needed to restore functions in humans if humans have some loss of limbs. And also, as people are, experiencing challenges with aging population, then again, in order to interact with people, there aren't that many people available who can fulfill that function, and therefore people are looking into robotics as a way of addressing that. So, but these robots again are currently potentially being thought about, being used in specialized facility, and prosthetic things that you are going to be using are not going to be, super intelligent. They are going to be very interesting mechanical devices or electromechanical devices, but they're not going to make any complex decisions. Transportation, again, lots of people want to use robots. People have been talking about drones for deliveries in congested areas. And of course, people have been talking about autonomous trucks for a while. So robots enable, time-efficient transportation. If you can basically build the right kind of pipeline of appropriately chained robot, you can create highly efficient transportation system. People have been, thinking about robot in food processing. So there are robots and restaurants where people are using robot to cook burgers, robot to make French fries. So all kind of interesting things are happening in that space. And again, robot improves safety in food processing because, in pandemic, there were lots of restaurants which were struggling because if you have a human workers, making the food, then they were concerned whether food is going to be contaminated or not. Now, if you have a robot doing it, then inherently you're not worried about contamination issues. So the interest from that perspective in deploying robots. These robots are also comparable in cost of the robot, which you see in agriculture or manufacturing sector. Then robots get used quite a bit in scientific exploration. So robot can explore inhabitable spaces deep under the ocean where it's very risky for humans to go, or explore volcanoes where again it's not possible for human to do it. Recently, we are seeing robots also being used in shops and grocery stores. So here, people are talking about, how can we again reduce workers so that, again, there are issues related with the worker shortage, whether pandemic induced or otherwise, then robot can take inventories, they can do mop the floors, they can do, a whole bunch of functions in basically shops and grocery stores. So it's a good time to pause and then basically answer. Actually, let me just present one more slide, then I'll come back and answer this question. Okay. So overall, robots are extreme machines and marvels of engineering, right? Robots on Mars have to endure extreme temperatures. So people have managed to build and design robots which can really endure extreme temperature. Manufacturing robots have to operate 24/7 for 8 years with virtually no maintenance. So people know how to design those. Medical robots have to exhibit a very high level of reliability. People know how to do that. We can manipulate very, very small things using optical or magnetic fields. So again, we have mastered the art of manipulating things which are invisible to naked eyes. So the remarkable technology exists and they can do wonderful things. And I highlighted for you many different applications where robots are currently being used. So now the question is, why are we not seeing robots at home besides Roomba and besides some lawnmowers that you can purchase? And the reason for that is the moment you start thinking about manipulating objects with a robotic arm, then complexity that comes with it, it increases the cost. So for example, let's say if you were to build a robotic arm, if it were to basically pick a dish from your sink and put it in your dishwasher, that robot is going to cost you right now $50,000, right? Now, question is, would you buy a $50,000 robot? I can give you one, but would you buy a $50,000 robot to basically pick the dish from your sink and put in your dishwasher? I don't think there will be very many takers for that, right? So once we start doing object manipulation, cost jumps up to the level of, $20,000+, right? So that's the first challenge that comes in. And actually, 50 would be lower end because you will have to integrate sophisticated vision and so on and so forth. Perhaps that robot will cost you closer to 100K, right? So obviously, the moment we start talking about manipulation, cost jumps up quite a bit, right? Second thing is that when I cannot engineer my environment around it and I cannot train the user to use it properly, then there is a significant risk that the reliability of operation will be very poor. So that means that your robot may work, 90% time, because everybody's home is different. Everybody's going to read it, use it in a different way. Or let's say, even if I get it to, work 99% accuracy, and that let's say you are picking, 20 plates a day, in a 5-day robot will break 1 plate. You're not going to be happy about that, right? So on the other hand, if you look at the other AI, which is being used, so let's say if Netflix gives you once in a while a bad movie recommendation, because it's also operating on unstructured data. So if Netflix gives you a bad movie recommendation one every 100 times, you're not going to be mad at it. You're going to just ignore it and move on, right? But if a robot breaks, 1 dish out of 50, 100 dishes that it handles, you're going to be super mad. You're going to be calling manufacturers, right? That's saying that, why is it my robot doing that? So a combination of cost that the technology has and the reliability that can be achieved in an unstructured environment. See, in manufacturing, you're not going to have the problem because I can design my work cell in such a way that, robot can sense everything and everything is in a controlled way. And therefore, you can have the reliability of 99.9999%, right? But when you're a totally unstructured environment, that's where the trouble comes in. And that's the same reason why self-driving car have not yet materialized, because again, that's an unstructured problem. And unless we start hitting those reliability numbers, which are supremely high, it's going to be tough to convince people that they should use it safely. So answer to the question is the cost and reliability that is expected. Those are the two barriers which makes it hard to provide people really useful robot to be used in home. Vilu, did I answer?
Yes, you did answer my question. Thank you. Thank you for that. Yes.
All right.
And I think Michael has a question.
Yes, thank you for all of this. This is really fascinating and amazing work in terms of the videos you showed us about what your company's doing, especially the flying bird. So I'm not sure if you've heard of a series called Deus Ex. Well, Deus Ex is centered around technologically advanced society where people have started to replace large parts of their bodies, eyes, legs, limbs, putting on exoskeletons, body armor, things like that, with the type of technology, the robotic limb technology that people are starting to use for people with disabilities. So I'm wondering if there's any speculation about people who don't even need these prosthetics actually modifying their bodies to enhance their strength or their speed.
So it's highly unlikely thing in the short term. And the reason for it is that while human body has a self-healing capability, none of the robotic technology happens to have it right now, right? So I think if you offer someone that, okay, I'll replace your perfectly, leg, which is working perfectly fine with a prosthetic leg, I don't think there will be very many takers, even if somebody said, okay, you can run, 50% faster, right? I mean, this is just speculation, right? I mean, I don't know what the answer is, right? Now, exoskeleton, absolutely. So people will start using exoskeleton. Exoskeleton is something that you are wearing on your body, and obviously as technology matures, then people will go for it. Prosthesis, no. Exoskeleton, yes, that's kind of my speculation, right?
Thank you.
Mm-hmm. Anything else that I can address right now?
So you mentioned like cost is really high, right? So even like in industrial or like even like in other areas, right? Not general public, like how are like companies like managing that cost who are using this technology?
Sure.
Right.
Yeah. So in that case, so remember I told you that a manufacturing robot cost about $50,000, right? Now, so let's say you equip the robot with the best sensor and you equip the robot with a good software and the cost to use $150K. Let's say hypothetically say that, right? Mm-hmm. And now let's add on that, okay, you will run another $50K per year in maintenance to run the robot, right? So $150K fixed cost, $50K basically recurring cost, right? Now imagine you are running a two-shift operation, right? So if you're running a two-shift operation, and let's say you're paying somebody minimum wage. So you are, let's say, hypothetically paying the person minimum wage. So let's say the cost to you is $30K for that person, right? Now remember, but if you have a person, you're going to have insurance and so on and so forth. So cost will most likely be double for you. So in that case, you can hypothetically assume that one shift operation person is going to cost me $60K. Now, if you're running a two-shift operation, it's going to be costing you $120,000 running a 2-shift operation with people, right? And the number that I gave you, 150K of fixed cost, right? And 50K of recurring cost, right? So every year you are saving 70K, right? And that 70K will pay off in less than 3 years, right? And the robot will last you for at least 8 years. So 50K robot, 2-shift operation, even with the minimum wage, is a good deal, right? If robot can do the task.
So it's like a longer term planning for the companies then.
Yeah, I mean, most people are looking at 3-year ROI, right? So yeah, so it works. Economically, it makes sense for them, right?
Mm-hmm.
So it's just a follow-on question for that. It would seem that replacing a human with a robot 1-for-1 may not necessarily be good for illustration, but may not be the way the companies would look at it. But they would have
absolutely. Yeah. Most people are not looking at that way, right? Most people would say, okay, and I will cover this topic a little bit later. Let's say you are doing robotic sanding, right? And you have 10 workers there. You may want to say that 10 workers, you know, I don't need it. I will use 3 workers. I'll pay them more. They will do more challenging tasks for me. And I will then use some robots. So that way everybody's happy, because again, right now in robot, when people are doing sanding, people quit their job after 2 weeks because the job is so tough, right? So it's difficult to find even workers who are willing to do that kind of work, right? In that case, the goal is that, okay, you can sand for 20 minutes, maybe every 4 hours. Rest of the time you manage robots. So your job is a lot more interesting in that case, right? So absolutely. So that's going on right now.
It makes total sense. Yeah. Thank you.
I have a question in this similar vein, and that is, what do you suppose are going to be the socioeconomic implications of robots taking over more and more menial manual labor tasks? And have you talked to any economists and predicted like what it's going to look like in terms of the unemployment for those people and compensating measures? Like maybe they could be upskilled into operating the robots or fixing them. Like, have you thought about that into the future?
So right now, so the data suggests, right, long term, I do not know. And I don't believe economists know long term what's going to happen, right? Short term, wherever people have deployed the robot the right way, it did not have any negative impact on employment numbers. Because people, I mean, either business grew and they could attract more business when they deployed robot. People found more fulfilling roles. So in the short term, there are enough reports out there which seem to be indicating that robot deployment has not had any significant negative impact on the employment picture. Now, long term, what happens, I do not know, and I don't believe any economists know either, right? Because what future opportunities are going to be there for people to, work on? Because, a lot of economists cite the old, numbers when society once upon a time, 80% people were doing agriculture. And then everybody was worried if the agricultural employment were to reduce, what will people do? And now modern society, we are talking in single digit people who are doing agriculture, right? But society is doing fine. What ended up happening is that as we shifted from, society which was largely based on agriculture to a manufacturing society, a lot of people shifted over to manufacturing. Now, even we have seen the transition that at least when manufacturing number went down, the service number picked up, right? So a lot of people went to service sector. Long term, what happens, I do not have any idea. But short term, we are not seeing an issue A lot of workers are very happy to learn how to, basically manage robot, and they are upskilling themselves, and obviously it's creating jobs which pay them significantly better than what they stuck to their original job, basically. Right? So people can triple their salary from minimum wage if they, become more in the domain of robotics. So.
Yeah, this is Roger. Just a further thought. I would think that robotics is just part of the overall direction of society in increasing productivity. So, we're using automation in a variety of ways to increase productivity,
Sure.
and robotics is just one component of that.
Exactly.
So SK, I have a question. In terms of future, where are we looking at problems? Where do we need to fix things? Is it on the hardware side, on the mechanics, or is it on the software side, or other things?
I have lots of slides for you, Vivek, in few minutes.
No problem.
Okay, so robotics is a multidisciplinary field. Robotics are really complex system. You have mechanical structures, actuators, energy management, sensors, electronics, software, human interfaces, and lots of applications use not one robot, but a team of robots, and of course humans as well. So, there's a lot of collaboration that need to happen between different disciplines. And that now brings in the challenges. So I'm just gonna try to answer Vivek's question. So how advanced are today's robots? So on the left-hand side, you have Boston Dynamics robot, Atlas, which if you have been following news and you've seen that, this can do backflips, it can do all kinds of interesting things and kind of a lot of press. And on the right-hand side is Michael Jordan. So if you compare the two, where are robots? So my response to it is that they're nowhere close to biological counterpart, right? Yes, robot can show some extremely impressive narrow feats, but when you think about what biological creatures can do, robots are nowhere close to biological creatures. So a lot of work needs to be done if we were to achieve, level of dexterity. And I'm not talking about intelligence. I'm just talking about dexterity, being able to manipulate the world. So a lot of work needs to be done. Okay, so where are the problems? So there are lots of open research problems in AI right now. We want robots that can program themselves because, again, a lot of manufacturing robots, people go manually code up what robots are going to do. Not a sustainable model. As we move towards manufacturing, where a lot of things are custom built, not going to work. Robot that can adapt to changes by conducting experiments. So if your sandpaper is wearing out, somebody had a slightly different material, and robot should be able to figure this out. Robot should be able to ensure safety. If one sensor is busted, robot should not break the part or itself. It should know, okay, sensor is busted, I need to get help. So lots of AI development that needs to happen. So this is one big open area. So lots of room for people to do AI. Sensors. So again, biological creatures have really exquisite sensing. Robots are beginning to use 3D vision, some force and torque sensing, tactile sensing, full body robotic skin. So these are all different technologies that people have been talking about. But these technologies are in very, very early days. In order for them to become really powerful, lot more work needs to be done in this field. So get anything which is human vision, or get anything how sensitive basically tactile sensing for human is, a lot of work that needs to be done. Materials, so again, biological creatures are made from multifunctional, self-healing, self-sensing materials. Robots are largely made out of dumb materials. So that means that if you want to impart capabilities to the robots, then again, it's very challenging right now. So a lot more work needs to happen in that space. Actuators, so robots are largely using electrical motors. I mean, if you take a look at biological creatures, all of them are powered by muscles. So muscles have some amazing properties. So again, we need to shift focus away from electrical motors to more artificial muscles. Again, work is happening in that area, but a lot more that needs to be done. Human interfaces. So, you know, right now when people are interacting with robots, it's very frustrating because, I mean, we are pushing buttons on a teach pendant or typing something in a computer. I mean, we really need to figure it out, different ways of interacting with robots. Now, people are beginning to talk now about augmented reality, and that might be the answer. So, but a lot more needs to happen in the interface space. People are also talking about, you know, just using speech to work with the robot, but speech alone, in my opinion, is not going to be the answer. It'll be some combination of speech, augmented reality, all sorts of other things, which will eventually allow, you know, human to interface with the robot in a much more meaningful way. So, did I answer your question, Vivek?
Kind of, you know, but what I'm saying is, where do you see the need? Is it on the software side that we have the ability, we have the motors, we have the actuators?
Both. My answer is both. I mean,
Both. Okay.
right now, we don't have the right AI, we don't have the right motors, we don't have the right sensors, we don't have the right interface. Lots of progress needs to be made in all those fronts.
Okay. All right. Thank you.
Okay. So, you know, Neelu asked me to say something about educational opportunities in this space. So right now, there are lots of opportunities available. People can do MS in engineering, where you can specialize in robotics, or there are MS program available in robotics. There's a PhD in engineering you can do with a specialization in robotics. You can do PhD in robotics. You can do BF in robotics. So lots of educational opportunities which are available for people. So there's a question from Elizabeth about, but what about the AI technologies and systems? You want to, Elizabeth, give a little bit more context behind your question, then I can answer it. Okay, all right, sounds good. So I'm gonna basically, since I had a lot of embedded videos, unfortunately that file was already a 800 MB. So I'm gonna show you a few more videos. So I'm gonna basically get on to a different file where I can show you a few more videos. So just give me a few seconds while my computer.
Yeah, my guess is that Elizabeth's question had to do with AI. So you were talking a great deal about robotics, and perhaps she wasn't hearing you talk much about the AI side, which I guess enables us to have smart robots. And AI is the whole software side of things.
Sure. I'm going to talk about that right now.
Okay, great. Thank you.
As soon as my presentation loads, I will talk about the AI.
Yeah, and I think Elizabeth just mentioned, and she said you addressed it.
Okay, so let's see. How are we doing on time?
We have time. We have about like 20 more minutes. I think we had it scheduled until 7:30.
Okay, sounds good. Okay, so let me try to get to the AI part of it. Okay. So most of my current work at University of Southern California is focused on basically AI for building smart robotic assistants. So just to get a little bit of context, today's industrial robot physically are capable of doing lots of things. But if you think about it, go to manufacturing companies in the US and you see where are robots being used. So robots are being used a lot of car companies in automotive sector. Robots are being quite a bit in electronics companies. But if you go to lots of aerospace companies, lots of other places, you don't see that many robots. And what's the reason for it? Actually, so before get to the reason for it, so that means that if you go to these companies, humans are doing these things today. If you go to a manufacturing company around LA, you will see lots of humans doing these things, which they should not be doing, because this is again, poses health risks for them. Why humans are doing this? So the way without AI, the way robots get used. So without AI, robot is just a machine. So if you have a new task, it will take you significant time to configure a robotic cell. You will need a human expert, which has to come to program the robot. And robot will just repeat the motion which has been programmed. You're not going to be having intelligence. And if error were to happen, it's going to take you a long time to recover from it. So that means that only people who use robots are the ones who are doing mass production. So if you're a car maker or electronics part maker, you use robots because you program it, run the line for a year, everything works good. Even though it took you 2 weeks to set up a line, it works. But if you're not doing mass production, then using robots becomes very, very challenging. And that's the reason why in US, there are 2.5 robots for every 100 workers. So that number, most people find it shocking that most people's guess would be, okay, we will have as many robots as human workers, but number is 2.5%. And the reason for it is that robots are dumb, the one which people are using in industry, right? They just repeat the pre-programmed motion. Now, what is beginning to happen now is that, there are lots of advances in robotics, in new sensing modality, new type of robot configurations, new control modality. So now people are talking about using really advanced AI to power the robot, as opposed to just go ahead and program the robot and use robot as a programmable machine. So AI is needed for 5 things. So number 1, we don't want humans to go program robot. So if you have a part that needs to be sanded by the robot, all you should be able to tell the robot, sand this part. You don't want to go program low-level motion saying, okay, move angle 1 to 36 degrees, move angle 2 to 38 degrees. You don't want to program it. You just want to tell the robot, here's the part, sand it. That needs AI. Then, if you have a new material that robot needs to sand, you should tell the robot, do your own experiment using self-supervised learning. Figure it out. What works, what doesn't work. And then once you have figured it out, the parameter, go finish the task. I don't have time to go back and tell you how to sand it, right? Another human will do the same thing, right? If I tell another human that sand this part, they'll figure it out. They'll do some experiment on some corner of the part and figure it out, right? The right setting is. So again, self-supervised learning is the integral part of, basically creating this robot. Then safety. So for example, if your sensor is not working well, you have a blurry vision. You don't want to go ahead and start executing motion and cause damage in the whole world. You really want to make sure that you can estimate what uncertainties are there and then manage it to make sure that you don't cause any harm. And again, you need AI for that. So you need real intelligent control to make sure you don't cause any damage. Things will fail. So sometimes robot will not be able to do the task which it is assigned. Rather than creating a mess or simply stopping, robot should have introspection capability, again, AI technology, where it's going to go ask human, hey, I'm stuck here, or I have very low confidence of finishing this task. Please come and help me. So again, AI is needed. Fifth capability is that if a robot has to communicate with human, then you need AI. Because again, if robot, the way previous generation of robots were communicating with human is just data dump, where robot says, I'll dump all the data that's there. It's not going to help any human, except somebody who has a PhD in robotics. It's not going to help. So you really need AI to manage the communication between human and robot. So robot can tell a human in an intelligent way, here is the problem, here is maybe the relevant data, here is what I'm seeing, help me. So again, AI is needed. So again, to summarize, the 5 roles that AI plays, and that's what we are developing right now. Make sure robot can program itself. Make sure robot can use self-supervised learning to conduct its own experiment. Make sure it's intelligent control, which will not cause any damage or hurt the robot, tool, part, or surrounding humans. Do introspection whenever its confidence is low or it's stuck, ask human for help, and use AI to effectively communicate with the human. So that's the big 5 major AI pieces that are being worked upon by my group and lots of other people. So this just shows you, AI capability where robots are able to generate motion plan automatically. There's nobody programming the robot. You're giving tasks to the robot, and robot is figuring it out how it can go ahead and move from one location to the other in a highly confined world by itself. Again, the same things. In this case, these are some very challenging tasks that robot need to perform following, contoured surfaces. Robot is able to do that. In this case, these are robots which are gonna figure it out which arm to use which task. So it can do assignment, saying the left arm, I'll do this task, right arm, I'll do that task, that's how I'm going to move. So all of this is being now powered by AI. We work in the lab, lots of interesting, exciting applications. In the interest of time, considering that I want to cover a few other topics, I'll just show you one more video. So this is a video where robot is inspecting a really complex contoured surface, and it will build a really good map. So this is technology which is used in inspection. Lots of other videos. Actually, this one also you might find it interesting. So here robot is doing 3D printing, but a typical plastic part 3D printing, if you have overhang structure, you have to print a lot of support material. In this case, you will show that there are 2 collaborating robots. So 2 robots are collaborating to do the printing. One robot is holding the base, other one is doing the printing, and both will then move in a synchronized manner so that no support structure printing will be needed. And therefore, you can now print all kind of very interesting structures, which after printing do not require any more, finishing operations. So all kind of exciting things which are beginning to happen in these kind of application areas. These are all videos from my lab, basically. So, yeah, so there's lots of exciting things happening in this space. Okay, so this is printing at very, very small scale, where we can do printing at a extremely small scale. Some more work on wire. Now, the final topic that I want to cover is basically, startup. So again, as I mentioned, I'm a professor at University of Southern California. So right now, tremendous interest from VC community to invest in robotics companies. So lots of exciting things which are happening in medical, manufacturing, agriculture, construction, and logistics space. I co-founded a company with a couple of my students in January 2020. We raised 20 million Series A round a couple of weeks ago. Our company is focused on basically robotic sanding, surface finishing applications. So currently, in millions of people land up basically working in this surface finishing tasks, which they shouldn't, because again, you are wearing a respirator, you're moving tool, which is vibrating, which will cause all kinds of problems. So we use advanced AI and sensors to give robot new capability. This just video shows how the technology works. A worker brings the part in front of the robot, secures the cart, presses a button, walks away. Robot will scan the part, build its 3D model, and then it will basically figure it out how to sand it, and it will go ahead and sand it. So that's how this particular technology works. So this is right now just scanning the part so that it can build a 3D model of the part. And then it has generated the path that it's going to use to sand it. And once it has the path to sand it, it's just simulating its own head to see if it works or not, and then it will start sanding it. So now it's sanding the part. This shows that this type of technology can do some interesting edge sanding type of thing. It's not just a flat region that it can do; it can also do sanding on these edge type of things. Now, other pieces that there's a tremendous societal anxiety about robot. Many people are afraid of robots. They think robots will take away jobs. Somehow, robots will kill all humans. In my opinion, there's no basis for robophobia. Data indicates that robots help in increasing employment. Wherever people have used more robots, employment pictures have looked good. Robots today work on human prescribed goals. So you task the robot to do tasks. That's what a robot does, right? Robot doesn't have, its own agenda or its own goal. You give it the goal and it will work on that goal. So if humans use robot in a responsible way, then robots are not going to cause any harm to humanity. If a human uses robot in an irresponsible way, obviously it's going to lead to bad outcomes. So that's kind of how things look today to me. So people who want to work in this field is rapidly changing. US, unfortunately, is not a leader in the field of robotics and automation. South Korea, Japan, Germany, Sweden are significantly ahead of US. But people who want to work in this field, they need to commit to lifelong learning. Things are changing super fast. It's a multidisciplinary field. So you need to get lots of perspective. It's not just a software problem. It's not just a hardware problem. I mean, my appointment at USC is between the School of Computer Science and Mechanical Engineering. So, I mean, I'm a half computer scientist, half mechanical engineer. And final piece of advice is that, human first. So we have to always make sure that when we are developing technology, how it's going to impact how humans are going to use the technology. So that's kind of my advice for people who want to work in this area. So in conclusion, I mean, innovations in human robot AI teams are needed to improve quality of life. There are numerous opportunities in the field of robotics and AI. And it is possible nowadays to go from research to commercial product within a few years. So with that, I'm going to stop and answer any final questions that you may have.
Regarding gray matter robotics, it seems to me that a lot of the focus seems to be the software side, because you guys are using a UR5 robotic arm. Did you guys have to face any mechanical engineering challenges at gray matter robotics? For instance, perhaps you needed to make a custom end effector for the sanding.
So gray matter, you correctly said, that largely focused on software. We try to not do too much mechanical engineering. Wherever possible, we try to get commercial off-the-shelf things.
Right.
We make most of our contributions in the space of software.
Okay, gotcha. Thank you.
But if needed, we do that, right? If
Right.
needed. So it's not that we are opposed to doing mechanical engineering work. It's just that the company's main core is AI. And whenever
Yes.
possible, we try to work with commercial off-the-shelf hardware. If needed, then we do some small, modest amount of work in that hardware side.
Gotcha. Makes sense. Thank you.
I have a question around security, and I'm wondering what considerations that your company or anything that you've been involved with have you had around security in terms of securing like the AI models or the network interfaces for any robots that would need to, be connected to Wi-Fi or cellular, things on that level?
Yeah, so in this case, basically, so it's again, purely from network perspective, we when we install a software, again, robot uses. So by limiting as to what changes can be made, how data can be acquired, by making it super limited is what we are doing to make sure that things do not get hacked, basically. And of course, most people don't run the robot while it is, on the internet, right? Because there's no reason for you to. You are running a robot controller next to it. So there are ways to limit your vulnerability. And then there are now NIST recommendations as to what you can do to secure your software. There's a DoD recommendation what you can do to secure your manufacturing software. So we are trying to follow those practices as well.
Do you think that there's a viable niche for a robotics and AI security specialist?
Absolutely. Because eventually, there are other domains where robots have to constantly be on the, in the internet, right? In manufacturing domain, you could just build a local cell and control it by a computer and completely isolate it. But there are many applications of the robotics where robots have to constantly talk to each other over internet, and then the tremendous opportunity in that space, how to, build really secure systems. And drones are great examples of it, right? So they're constantly talking to the ground station, being tasked, and then beaming the sensor back, right? So data back, so yeah. Manufacturing is a little unusual in that sense that there, you can disconnect the things from internet, things will still work fine. You will need, when you need to go mine the data or you need to give it a software upgrade, that's the only time when thing has to be connected to internet, right?
Then you just need to make sure that the people operating that and programming it are secure and the right people.
Absolutely. So yeah, so the different challenges in manufacturing than some other application areas where, you're constantly on the net and you can be hacked by others and so on and so forth.
Thank you, Dr. Gupta. I think this has been very informational and it answered a lot of questions I had on robotics.
So happy to help.
Thanks, SK. Mr. Gupta, this is a very interesting conversation. Unlike a lot of other IT things, robots are things we can see, feel, touch, and look forward to. But that was very enlightening. Thank you.
Happy to do it, and thank you for inviting me.
All right. Thanks, everyone. So we'll be ending this presentation. Have a good night.
Okay. Good night.
Good night.
Night.
Thank you so much.
Thank you.
Bye.
Bye.